In this section of the course, we're going to be looking at Newton's law of universal gravitation. This corresponds to sections 12.0 through 12.2 in your textbook. So chapter 12, pages 1, 2, and 3. Please make sure you have read and completed the interactive exercises in these sections before watching this video. If you have not completed those, please pause the video, go back and watch those before continuing. Newton's law of universal gravitation is a way of finding the force of gravity. Force of gravity is based on two different things. It's based on the mass of the two objects that are attracted towards each other and the distance between them. The mass of the two objects is one of the key features. The distance between them is the other. The farther apart they are, the less force of gravity you're going to get. The larger the masses are, the more force of gravity you're going to get. So there's a direct relationship between mass and force of gravity. There's an indirect relationship between distance and force of gravity. You will generally see this written the following way. The first symbol in the equation is the big capital G. Capital G is the universal gravitational constant. It is a number. It always stays the same. It is 6.67 times 10 to the negative 11. It is always that value. This is a constant. It is important that we know this number. Generally, you'll be given this number on tests and quizzes, but you do need to be able to use this number when solving these problems. The rest of the equation, m1, m2 over r squared. You'll generally see r squared here. You may see it listed as d squared. I think d squared makes a little bit more sense because it is actually the distance between the two objects that we are looking at. So any two objects that have mass are attracted to each other by the force of gravity. Now because the gravitational constant is so small, 6.67 times 10 to the negative 11, if the objects don't have a lot of mass, we're going to get a very small force of gravity. But if the objects do have a large mass, then we get a large force of gravity like planets, suns, and the Earth. Let's look at some example problems we can solve with this equation. Find the force of gravity between a 100 kilogram mass and a 750 kilogram mass that are placed 1 meter apart. So we're going to be using the equation F equals G equals G m1 m2 over r squared. We're looking for the force of gravity here. So G 6.67 times 10 to the negative 11, always that value. M1, so the first mass. It doesn't matter which mass we call M1, which mass we call M2. You're multiplying them together, it's the same. These masses do need to be in kilograms, though. Second mass, 750 kilograms. Divided by the distance between them, which should be in meters, squared. So in this case, we'll have 6.67 times 10 to the negative 11, 1,000 kilograms of mass. The distance between them of 1 meter. Now for calculating, it's pretty straightforward. Multiply 6.67 times 10 to the negative 11 by 1,000, multiply that by 750, divide by 1 squared. We get a very small force of gravity here because this is indeed very small masses in terms of gravity, only 1,750 kilograms. It's not going to be large enough to have a significant force of gravity. And we get 5.00 times 10 to the negative 5th newtons is our answer there. A very small force of gravity. They are close together, but they're relatively small masses in terms of gravitation as a force. Second example problem, now we're looking at some bigger objects. The sun, the Earth, looking at much larger distances. So we want to find the force of gravity between the Earth and the sun. The sun has mass of 1.99 times 10 to the 30th. Earth, 5.98 times 10 to the 24th. The distance between them is 1.50 times 10 to the 11 meters. So very large distance, but we're looking at here huge masses, 10 to the 30th, 10 to the 24th kilograms, which is why we get a substantial force when we talk about the sun, the Earth. So G, M1, M2 over R squared. F of G, 6.67 times 10 to the negative 11. M1, doesn't matter which mass we use as 1. I'll use the sun since it's the first one listed. M2, 5.98 times 10 to the 24th. And then divided by the distance between them squared, 1.5 times 10 to the 11th meters, and that value is squared. So we're going to multiply 6.67 times 10 to the negative 11th times 1.99 times 10 to the 30th times 5.98 times 10 to the 24th. Divide that by 1.50 times 10 to the 11th squared, and we get a force of gravity that is very large here, 3.5 times 10 to the 22nd newtons. A very large force of gravity attracting two very large masses towards each other. And we're talking about the sun and the Earth. When you're doing this, make sure with your calculator that you either be very careful with parentheses or that you use the E button, second comma, when using exponential notation.